You're listening to the N2K Space Network.
Imagine a world where you're always one step ahead of cyber threats, where your defenses are impenetrable because you see what others don't. Welcome to Team Cymru's Threat Intelligence Solutions. With real-time access to the world's largest threat intelligence data ocean, they enable you to turn the tables on attackers. Transform your security from reactive to proactive through accelerated threat hunting and incident response, made possible through automation. Empower your team with visibility and insights to start defending your organization like never before. Team Cymru. Be the hunter, not the hunted. Learn more at team-cymru.com/cyberwire. That's team-cymru.com/cyberwire.
There are 10 new NASA astronauts now fully trained, ready, and able to take on all of the space challenges of the Artemis generation. And yesterday, they graduated from candidate status to full astronaut. No more rewards and tassels, though, but you are absolutely free to hum, pomp, and circumstance if you wish. Congratulations to the NASA astronaut class of 2024.
T-minus 20 seconds to LOS T-dress. Go for deploy. Roger roll.
Today is March 6th, 2024. I'm Maria Varmazis, and this is T-minus. NASA calls for their next class of astronauts. Terran Orbital wins an IDIQ contract from NASA. The UK announces up to £160 million for its Connectivity in Low Earth Orbit program. And our guest today is Dr. Elaina Hyde, the director of York University's Allan Carswell Observatory. And Elaina and I will be chatting about the solar cycle and what effects the solar maximum can have here on Earth and on objects in orbit. Let's dive into today's intel briefing, shall we? From ASCANs to astronauts, the latest astronaut candidate class at NASA graduated yesterday in Houston. And now there are 10 new astronaut graduates, ASGrads, who started their training back in 2021 from an applicant pool of more than 12,000. Yeah, that's an acceptance rate of 0.083% for anyone else doing back of the napkin math there. Yeah, competitive. These 10 new astronauts are now ready for mission assignments, from flights to the ISS or commercial space stations to perhaps even to the moon or to Mars. And alongside these 10 astronauts graduating, I should mention that 2 additional astronauts from the UAE also trained with the NASA astronauts and have graduated alongside their colleagues yesterday. And with this class moving up and onward, if you're thinking there's space for a new group of candidates, yeah, you're right. So if you think you're a good fit for the Artemis era, applications are once again open. There are a whole lot of musts for any astronaut candidate or ASCAN. U.S. citizenship is one of them, and there are educational and experience requirements just to start. But yeah, there's a whole lot more. And honestly, it's kind of an interesting read to learn about all those requirements, even if you're not going to apply. So whether you are or not, and best of luck if you are, we're posting the astronaut candidate job application in our show notes for you. And to all applicants, remember, it's as can, not as cannot. We're rooting for you. And speaking of astronauts, yesterday was Super Tuesday in the U.S., which is the presidential primary election day when the greatest number of U.S. states hold primary elections and caucuses. I promise this is not going to get political, but I just want to say, what do you do when you're out of the country, or in this case, out in space, and you want to vote? Well, 2 astronauts on board the International Space Station shared that they had voted from the orbital lab in the primaries. Laurel O'Hara took to the platform X to announce that she and Jasmine Mugbeli had cast their votes, so no one had an excuse not to participate. You cannot escape politics even on orbit. No, you cannot. And moving on, Terran Orbital is all over the news this week with possible buyouts and new contract announcements. We're on day 3 of the working week, and it is now the 3rd time this week that we're talking about them. This time, the company's been awarded an Indefinite-Delivery, Indefinite-Quantity, or IDIQ contract with a $45 million ceiling value by NASA's Space Technology Mission Directorate. The 5-year agreement enables Terran Orbital to provide space vehicles and payload integration services for a variety of missions. These missions will use Terran Orbital's proven space vehicle platforms and are intended to advance technological maturity of systems that will transform the landscape of space exploration, discovery, and space commerce. In other news now, Agile Space has received a Small Business Innovation Research Phase 2 contract from SpaceWorks, which is the Space Force's innovation hub run by the Air Force Research Laboratory. SpaceWorks awarded the contract to Agile for its Mobile Payload Processing Center, which will enable the U.S. government to increase mission effectiveness in remote locations. Now, Agile was one of 19 companies selected as a winner of the 2023 SpaceWorks Tactically Responsive Space Challenge. It's also known as TAC-RS, and it's sponsored by the Space Safari Program Office at USSF Space Systems Command. And that office identifies cutting-edge TAC-RS concepts that enable the Space Force to respond to the most pressing challenges and emerging on-orbit threats by 2026. And staying with SpaceWorks, the Space Force's Commercial Space Office says it will soon be granting $40 million in small grants to commercial firms for technologies to provide alternatives to GPS. The office expects shortly to issue direct-to-phase 2 small business innovation research grants to contractors that are involved in the Alternative Positioning, Navigation, and Timing, or ALT-PNT challenge. And this challenge was launched last November by SpaceWorks. Elvay Incorporated has closed a Series A round of $15 million from a selected group of investors. And Elvay is a manufacturer of high-efficiency, lightweight, millimeter wave power amplifiers that enable wireless connectivity beyond 5G. The company says it plans to use this funding to grow its customer base in the space connectivity market and to increase manufacturing capabilities. Space robotics company Gitai has successfully demonstrated its robotics technology for constructing a 5-meter-high communication tower in an environment that simulates the lunar surface. The project was led by Gitai USA in collaboration with its customer, KDDI Corporation, which is one of Japan's largest telecommunications operators. May we humbly suggest checking out the video of the Inchworm robot and lunar rover in action by following the link in our show notes. It's super cool. Okay, over to the UK now, and the UK government has delivered the spring budget, and it includes up to $160 million for the Connectivity in Low Earth Orbit program, which is also known as CLEO. The funding for CLEO aims to enable UK researchers and businesses to perform the development needed for the next generation of satellite constellations. The first funding call for the program is expected in the coming weeks. And staying in the UK government has announced a £10 million investment in Saxiford Spaceport as part of the island nation's spring budget. Saxiford says this latest investment will help the launch facility to capitalize on the rapid pace of construction as they work towards the first ever orbital launch from UK and European soil. And staying in the UK again, the private sector investment firms are making moves to assure the UK space industry. Meridian Space Command has moved to the University of Leicester's £100 million Science and Innovation Park. The company helps space sector organizations to secure funding for and complete technology demonstration missions, which enable them to expand into commercial markets. This move will also enable Meridian to collaborate with the University of Leicester and to showcase its offering to businesses, ranging from industry giants to innovative startups, in and around the Space City Leicester cluster. And over to India now, and Dhruva Space and the Swedish Space Corporation, which is also known as SSC, have announced a collaboration in the realm of satellite ground station networks. The move aims to help accelerate the growth of Swedish and Indian new space industries initiatives. Dhruva Space will be leveraging the SSC network of ground stations for Leap 1, which is an upcoming hosted payload satellite mission, which is slated for launch later in 2024. And that's it for our intelligence briefing for today. We've included links to further reading on all the stories we've mentioned in our show notes. And we've added a few extra stories for you today. One's asking if it's time for a new outer space treaty. One's on the Voyager 1 mission, and the last one is commentary on Florida, keeping up with commercial space travel. All those links and more can be found on our website, space.n2k.com, and just click on this episode title. Hey T- crew, if you find this podcast useful, please do us a favor and share a 5-star rating and short review in your favorite podcast app. That'll help other space professionals like you to find the show and join the T- crew. Thanks so much. We really appreciate it.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
Our guest today is Dr. Elaina Hyde, director of York University's Allan I. Carswell Observatory. And I don't know about you, but I've been hearing a lot about the solar maximum. And sometimes there's hype about solar maximums potentially causing outages due to increased space weather. So, to learn more about this, I started by asking Elaina, what do we mean by a solar maximum?
If you are projecting the sun in a safe way, there's some great things you can look for on the solar surface. You can look for sunspots, which are areas where the magnetic field has tangled up and they look dark on the sun. But that's just because the sun is incredibly, incredibly luminous. The sun is a giant ball of roiling gas. It's stable because gravity holds it together. But it is a roiling ball of hydrogen plasma, which means it's incredibly hot. It's moving around all the time. It's pressurized. It's active. And it has a strong magnetic field. And that magnetic field gets tangled up because, of course, it does. It's in this roiling ball of gas. And as the magnetic field gets tangled, it creates these little sunspot areas where the gas is sort of depressed. It can also help the gas to kind of loop up off of the surface, which is what we get for when we talk about prominences. There are these beautiful little loops of gas just coming off of the surface. Flares are when you get sort of little bursts of energy coming off. And finally, the funny one, which is the coronal mass ejection, which is a large piece of material sort of coming off of the sun in a big blast. And if you want to see some of these, you can actually look online to some free live action telescopes. I particularly like the SOHO, the Solar and Heliospheric Observatory. They put up pictures, and what they do is they use different wavelengths to help bring out different features of the sun. Now, for hobbyists and things like that, you might be able to find filters that help you see these events with their telescope. But the people using pinhole projectors and cameras, mostly you're going to be able to see the sunspots. And so being able to identify the features on the sun, you'll see that they change over time. The sunspots move around. They're huge, many of them, and I would say most of them, are larger than the planet Earth would be if it was up there.
That puts it in perspective, yeah.
Yeah, so they're very large features. They just look small because it's the sun, and the sun is massive. And so you get these sunspots, and we can watch them move around the sun. We can watch them become more. We can watch them become less. And we have been. So people have been watching the sun since the first sort of projection techniques were written down. And observations have obviously gotten a little better in that time. So we have better data now than we used to. I think it goes back a pretty good ways. And what you'll see is that sunspots go up, sunspots go down, sunspots go up, sunspots go down. And around about 1700s or so, we started getting some pretty good regular data for sunspots, and people became more and more convinced that the sunspots were going up and down in a regular pattern. And it turns out that it looks like every 11 years. So every 11 years, your sunspots go from up, so lots of sunspots to more lots of sunspots, and it goes in sort of a little sine wave. So you have, and right now we're in 2024, we've got 120 odd sunspots being charted, visible on the sun. But back in 2020, it was pretty close to zero. So when you have an absolutely sort of low point, it's actually completely clean. You look at the surface of the sun, there's not a sunspot to be seen. And so you go back again. So we're going 2024, we're seeing over 100. 2020 was pretty much zero. 2014-ish, over 100. And so on and so forth. Off it goes. So you get this going up and down and up and down. And some years have more, some years have less. Now, more sunspots, meaning more like 100 sunspots rather than zero, right? So the more sunspots means more activity, more chances for flares, more chances for prominences. But interestingly, the really big eruptions, the ones that are potentially damaging to lots of equipment on Earth, those ones seem to be able to happen whenever kind of deal.
Do they happen more during a solar maximum year or no?
We just don't know because there just have not been that many of them. And we don't have that good of data for them. But it doesn't seem like, and this is, may be anecdotal, it doesn't seem like more sunspots means more coronal mass ejections. It does mean more of everything else. So you get the more flares, just more charged particles in general, better northern lights, so aurora, and of course, more chances of viewing prominences if you're out there with your solar telescope. But the really, really big ones, the ones we're really worried about, unfortunately, those seem to be pretty hard to predict. And since we're right now in 2024, looking at over 100 sunspots, one of the questions that people have been asking is this the maximum? We don't actually know, because sometimes the maximum goes up to around 100. Sometimes the maximum goes up to like 200. Sometimes the maximum goes up to like 300. So we're not actually in a point where we know how high this maximum is going to get because we haven't seen it drop off yet. So until we see the number of sunspots decreasing, we won't actually know where the maximum was.
Hence people saying approaching solar maximum as opposed to because we don't know when it's going to arrive, so to speak. Yeah, okay.
It's one of those funny things about watching the data is that you don't actually know when it happened until it's already passed, because until the number starts going down, you can't say what the maximum value was. And if folks want to follow along on this, there's a wonderful sunspot cycle tracker on the NOAA. And it'll show you the current sunspot cycle. So we're in sunspot cycle number 25. And the NOAA is the National Oceanic and Atmospheric Administration. And there's a lot of people who are really interested in watching and predicting the sun, because it's sunspot cycles don't affect the temperatures here on Earth much, but a really, really extreme event might. For example, the Maunder minimum, where the maximum values of sunspots were only in the 50s for sort of 2 or 3 cycles. So the maximum stayed low for several cycles in a row. And then, of course, you can have higher maximums as well. So, you have the 1950s had that one that was well over 300. And so, small things like that can have little effects. So people are interested in kind of watching it and seeing, and, how predictable is it and how high will we get now, right? So this is 2024. Is it going to peak this year, next year, 2026? I mean, maybe. So some of the graphs do show that maybe we might actually not peak until 2026 with the sunspots, which would mean that several more years of good solar viewing, and watch out for your satellites. Well, and auroras.
Yeah, well, I mean, that's sort of the question that I have when I think about just solar events in general, because there was a cell phone outage that happened in the United States a week or two ago, and I remember a lot of people going, oh, it must have been a solar flare, and it wasn't. But a lot of people just kind of jumped to that conclusion. And there's also similarly as we hear about solar maximum, people are like, oh, satellites are going to start falling out of the sky. I mean, we know that that's not how it works, but...
Well, and the thing is, there's several things that happen at the same time, right? So solar maximum does mean more charged particles in general, right? So our magnetic field has to handle more of those charged particles. And what does it do with them? Well, it sends them to the poles. So it tries to send the charged particles up to the north and down to the south poles. And that's where they start interacting with the atmosphere. That's how we get the northern lights. But if you have a solar flare, then you get more particles arriving all at once. And that's where you can potentially get, more outages, as well as satellites falling out of orbit. SpaceX, they've lost a lot of satellites.
Yeah, and I think they bake that into, yeah. But I mean, not literally raining on our heads is sort of what I think people were thinking of. Like,
well, and it's gotten to the point now where they've lost so many satellites that people have been able to measure the increase in metallic particles in the atmosphere due to actual satellites breaking up, which is a whole other thing, because it never used to be. It wouldn't have even been thought of as a problem. The pollution of the upper atmosphere by satellites burning up. But when you have a huge number of them, and you have to say, okay, well, what kind of metallic particles are they putting in there? And is it going to be a whole different level of atmosphere problem once more of them start burning up?
Anything else that we want to mention about space weather or the current solar situation as a wrap up, I suppose?
Well, I think, for folks who are interested in the space weather applications, just be aware that, your solar storm dangers are really basically, it can cause damage to electrical grids. It can cause blackouts. They can damage satellites and GPS services. But internet and live services are especially vulnerable. And so if you are wearing a medical device that does constant monitoring for you, please be safe and be cautious, because live services and things that require constant connection are extremely vulnerable. They're not something that we would have ever had before. Satellites, of course, can be pushed out of orbit and burn up. Astronauts in the ISS, they do actually have protected areas that they have to move into. And, the amount of effect that we can look for will depend on the amount of material from the sun that our planet has actually run into. So even if there is a coronal mass ejection, if it's pointed in one of the other many directions in space, it's not a problem, because it won't hit us. So only worry if you hear about some massive prominence that's erupted on the sun. Don't necessarily worry unless you hear that it's also an Earth intersecting one.
We'll be right back. Hey, welcome back. Sometimes a story comes across the desk here at T-Minus Studios that is so in my wheelhouse that it's not even funny. Here's one I immediately sent to just about everyone I know. Brace yourself. NASA has made a tabletop role-playing game. It's called The Lost Universe, and I know the Venn diagram of space nerds and TTRPG nerds is not exactly a circle, but it's got to be pretty close. So get your bag of dice, dust off that DM screen, and gather your party of between 4 and 7 players and venture forth into a mysterious wandering exoplanet. Here's the sizzle and spice about the game from NASA. A dark mystery has settled over the city of Eldastron on the rogue planet of Exlaris. Yeah, these are not real places. Researchers dedicated to studying the cosmos have disappeared, and the Hubble Space Telescope has vanished from Earth's timeline. Only an ambitious crew of adventurers can uncover what was lost. Are you up to the challenge? Oh, NASA, are we ever? They combined the Hubble Space Telescope and dragons, y'all. Now, this game is system agnostic. I know some of you are asking that question. And all of the game materials, including the game manual, are freely available online. And there's space science in this game, of course. Would you expect anything less from NASA? And actually, there's a pretty decent amount of it. But did I mention also that there are dragons? Yeah, that's my Friday night sorted. Well, once all the players can agree on a time to meet up and we figure out who's going to DM. Alas, logistical issues transcend universes. That's it for T-Minus for March 6th, 2024. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in this rapidly changing space industry. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jen Iben. Our VP is Brandon Karpf. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.